My name is Vinay Mittal. I am representing the Group 9 for the AAI 540 program. We have created an ML prediction system end to end using AWS complete pipeline, including the ML ops pipeline. I'm going to represent the Group 9 completely. So here it is. We have at the left side we have the Git profile. At the right side we have the document which I am going to submit. This repository has all the codes which I have coded. This also has the notebook which has the results with it. First, I'm going to walk you through the overall project scope and what's the background. So, this project is mainly a statement which every financial technology company at some point of time, faces, which is to know if the loan is going to be recovered or not. So, which is what we're gonna predict in this project. It's a multi-class project rather than a binary classification. We'll be predicting these three classes which you can see on the screen, which is first is to know the fully paid or is it charged off, and what is the loan status, right? So as I mentioned, that the primary objective of this project is to demonstrate a complete production ready MLOps pipeline, that too using AWS platform. Now, talking about the architecture, as I was mentioning that we used AWS, so this completely has all the data which is invested on S3. Um, then into Athena for doing the analytical querying. I will be showing those queries as well. We also use AWS SageMaker feature store across two feature groups. One is the loan level and the borrower level. Then we have also gone through the AWS training jobs, SageMaker training jobs. We did used an ML M5X large machine. The ML model was XGBoost, and post that we also use SageMaker model registry to register the models so that we can use them post our training. The approved model is deployed as a real-time inference endpoint with data capture enabled, so that can be feeded into SageMaker model quality monitor that runs hourly and triggers the CloudWatch alarms if accuracy drifts, right? So that is around the AWS pipeline, including deployment and the monitoring, which I just discussed. Now, talking about the dataset, this dataset was available on Kaggle. This was originally sourced from the Lending Club. This is a platform which has the data from 2007 to 2018. We borrowed for the 2016. Um, from 2007 to 2018, they have millions of rows, but we only borrowed for the scope of this project for 2016. This is around 4.5 lakhs of rows, and this is how the distribution looks like. Key columns we used are this. So the main target variables is the loan status, whereas this is the features we have. Now, talking about the methods which we used in this ML problem was, the data engineering, the feature engineering, the model training and evaluation, and post training evaluation. We did the deployment as well using the SageMaker real-time inferencing endpoint. Then we did monitoring as well, the model quality monitor of SageMaker, and finally the CI/CD pipeline. The complete structure of this repository is being shown on the screen. All the scripts, individual scripts are being coded. We also have the final main notebook which shows the demonstration. I'm going to pick it next. These are the location at the S3 where we have stored the raw CSV, the Parquet file or the data lake, the training and testing validation split are here, and the model artifacts are here, which can be picked later for their inferencing. Now, the details of the AWS infrastructure are like this. This is the same account which is allotted by the University of San Diego for me. I haven't exhausted the $50, so this was remaining the same during my earlier project as well. Next, I'm going to walk you through the code completely. So here is the notebook which shows the demonstration of my code. This notebook is utilizing the data directly from the downloaded Kaggle dataset. I immediately stored that on S3 and then posting on the S3. I put it into Athena. Here is how it looks post. Ingesting it into Athena. I have tried with some of the queries to make sure that the Athena is working fine and is queryable. Here is some exploratory data analysis for us to see how the data distribution looks like. We can go in details of this. What are the key features and what's the charge of rate by loan grade? Now, talking about the Athena SQL queries, I was curious to know the overall class distribution. So I read this query, and this is how it resulted into. I also had the average interest rate and the loan amount by loan status. So the loan status um, is more likely to have two, then this is how the average interest rate is. Talking about the charge of rate by loan grade is how it looks like. The top 10 loan purposes by volume. So most of them are into debt consolidation. Now, talking about the feature engineering part, which is where I used the AWS feature store. I stored my features which are most important, and complete rows. I did that for all the rows, and I later on utilized that for model training as well. Here, as you can see that it shows me the result from this feature store. I also did. I created two groups here. One group was for the loan features, and the other one was for the borrower features. Then I ingested that into the features too, and I just verified it if this result is being shown or not. Post storing, I did the model training. Model training is used using the XGBoost. I also did the evaluation of those models again on the SageMaker itself. The result something looks like this. This is the confusion matrix. The overall test accuracy is 90%. The confusion matrix is plotted here. The feature importance were like this. Talking about the model registry and the model package and model card, I did store that into AWS model registry. This is something similar as we store Docker images at ECR. So this is particularly for the models. Now these are the results which shows that this is being stored. We inspected it, described the model package group, and we inspected it. The version is being shown here. The model packages details are being shown here, and the model card is created here. Now, talking about the deployment, again we have a real-time SageMaker endpoint with the data capture enabled. So this is where the endpoint is deployed. We try to test at the same endpoint, and this is how the results looks like. Post deployment, we also did the quality monitoring as we want to see if there is any drift in case. So we initialize the model quality monitor on the same type of machine, and this is how the statistics looks like around the model monitoring. Now talking about the CloudWatch alarm, where we want to store the logs of this monitoring something. So we have created a CloudWatch alarm if in case there is an accuracy drop in our model. So this is all around the code. We used AWS end to end, and the MLOps pipeline is also deployed at AWS. Thank you. This was Group 9 AI 540 by Vinay. Thank you.